So don't feel that the repetitive will be done by my colleague in the afternoon or somebody talks on that. MPLS. Again, there will be a lot of apprehensions. What is MPLS and what is the difference between MPLS and IP-MPLS? MPLS and IP-MPLS both are same because MPL is approach is possible only with IP. That's why some people call IP-MPLS or it is MPLS. Both are the same. There is no difference in between. What is MPLS? MPLS stands for multi-protocol label switching by name itself. It is a standard which provides high performance method of forwarding packets or cell through a network by combining, this is very, very important, combining layer 2 switching technologies with layer 3 routing technologies. Yesterday, this is the reason why we started with our session with the OSI reference model to make you to understand or to refresh ourselves what is a layer 2, what is a layer 3, and what are the different components that works on layer 2 and layer 3. The layer 2 is switching, and some of officers are also asked what is the switching, which layer 2, layer 3, and there is a special switch of layer 3 also available. We already spoke on that. So MPLS works combining the two layer technologies, layer 2 switching and layer 3 routing. This is very, very important if you can need to understand on this. MPLS is defined by the Internet Engineering Task Force IETF. It has come in force from 97 itself. There are the standard bodies across the Internet, IETF, which you are all aware, OIF, Optical Internet Networking Forum, for connecting gigabit Ethernet connectivities, or packet over DWDM, packet over SDH, ODSI, Optical Domain Service Interconnect, and ITUT, anyway, you are aware that International Telecom Union. Why MPS? I think this is the question where I want to just touch upon. Some of my senior officer will talk on existing railway legacy network to move into this MPLS. Why only to MPLS? See, today we have started our, long back we started our journey from basic analog telecom to the digital telecom to the TDM to the non-TDM. Non-TDM is nothing but IP. When we started our career and we was talking into the many forums, I used to talk, voice is going to become free. This I used 10 years back. Voice is going to become a free. People laughed at me. What hell is he talking? But today, we are all seeing that voice is free. Pukat, even data also free. Pukat, 3 months free, 4 months free. The scenario. So, total our TDM concept is totally changing to the IP. That is TDM to the IP. Why? We have started using different equipment. N into 64 started with 64 kbps, 512. Still, your railway voice circuits uses 2 Mbps even circuits, but they are not even supporting your Ethernet now. It supports only evens. So, traditionally the fractional rate delivery of a typical TDM is getting exhausted into the public usage. People talk about megabits, gigabits, terabits, yotabit, jotabits, petabits. When the requirement is like that, even when you railways also, when you start using RDN or different video surveillance systems, when we was all, you need a big pipe. You can't run existing on your STM1s, you can't run on existing E3s, you can't run on existing E2s. And of course, the ruled out E2. So when you want to leverage all the applications, usages into the common platform, the Ethernet is only the best option. That Ethernet, that to secure Ethernet, that is possible with MPLS VPN. So that's the idea of bringing all together into the common media. Again, somebody will ask, only MPLS is the end. No, there is beyond MPLS, other technology has to come already in the market now, called SD-WAN, software defined wide area network. which gives better features than MPLS at cheaper cost. You may ask me a question, why not we going to SD-WAN? I'm not the deciding authority or answering authority for that, but it is available. I will just throw light onto it also to make you to aware what the trends of the industry is. So earlier, before this, the TDM technology, we have an ATM technology, asynchronous transfer mode. It works on a cell. It basically into the packetized one. So that technology in earlier golden days, whenever we want to transmit data, we have a separate link called packet switching. When we want to send a voice, that is called circuit switching. When we want to send a TV channel's video, a separate channel. So different networks have been used to send different type of the services. Voice, video, data, you can't send in common pipe. To address all these needs and deeds of the market, the ATM technology is brought into the picture, which converges all these three into the common pipe called PVC, permanent virtual circuit, permanent virtual path, creating that ATM. ATM has got its again own disadvantages, 48 bytes of the payload and 5 bytes of your overheads, totaling 53 bytes. It is called a cell. Having challenges this, now we moved to the MPLS. MPLS can work on ATM as well. So the MPLS stands for multi-protocol label switching. It is forwarding the package fast. It has got a fixed length of the packets. And the main question today, the challenge in the industry is, we are getting a voice data today at cheaper rate, throwaway price. In India, is a cheaper across the market, the global market. We get 1 GB at a rate of 18 rupees. The same 1 GB cost in other locations, $75. Again, why? At what cost? That is the traffic engineering, IP traffic engineering, that is class of service, quality of service, grade of service. All these parameters you can't check in normal, the topologies what we use. It is possible only when you start using MPLS. Of course, to some extent, it is possible in ATM technology, but ATM technology is not become popular. So people have migrated and adopting to the MPLS technology. So the traffic engineering is the best way. Can be, yeah.
सर बीच में हिंदी में थोड़ा ब्रीफ करते रहेंगे तो थोड़ा सही रहेगा सर.
ठीक है सर, मैं कोशिश करूंगा ही, क्योंकि मैं कोशिश करूंगा. अभी देखिए, अभी तक हमने क्या बात किया था कि अभी तक हमने पूरा अपना जिंदगी जो है आज तक मैक्सिमम हमने TDM बेसिस में यूज किया हुआ है. वेयर वी यूज E2 है, E3 यूज किया है, E4 यूज किया है, STM1 एंड STM4 that is 525, 625 and we use STM16 2.5 gig ऐसा यूज किया हुआ है. अभी क्या है, देयर इज अ लिमिटेशन फॉर यूजिंग. हमारे पास कोई लिमिटेशन था कि फ्रैक्शनल रेट यूज करने का. अभी कोई मार्केट में वेंडर भी सपोर्ट जो है, अभी आपका फिबकम यूज कर रहे हैं आप, अभी का फिबकम का सपोर्ट ज्यादा मिल रहा है एंड तेजास यूज कर रहा है, तेजास भी ज्यादा मिल रहा है, बिकॉज द होल वर्ल्ड जो है चेंज हो रहा है. जब भी चेंज हो रहा है तो द ईथरनेट इज ग्लोबल एडाप्टेबल. आपको क्या कर सकता है कि अगर जब भी आपको कोई चेंज कर रहा है, अगर रिंग आपको ऑगमेंट करना है, रिंग को बढ़ाना है, पूरा आपका इक्विपमेंट उस रिंग में आपको ऑगमेंट करना पड़ेगा. STM1 से लेके STM4 तक कितना कॉस्ट लगेगा, कितना टाइम लगेगा, कितना प्रोक्यूरमेंट टाइम लगेगा, कितना आपका स्टाफ को ट्रेन करना पड़ेगा. जब ईथरनेट इज अ कॉमन मॉडल, जस्ट प्लग एंड प्ले. तो MPLS प्लग एंड प्ले. अगर ऑगमेंट करना है तो स्टार्ट फ्रॉम आप Mbps से लेके गीगाबिट से लेके टेराबिट्स तक सेम पाइप आप यूज कर सकते हैं. तो इसलिए जो है एक सीमलेस ऑगमेंटेशन के लिए आपके लिए ये MPLS प्लेटफॉर्म ये सही है, राइट प्लेटफॉर्म है, इज ऑर्डर ऑफ द डे है. देयर इज अ वे. एंड इसमें क्या है कि क्लास ऑफ सर्विस आपको क्वालिटी कैसे चाहिए. अभी now earlier is the days people used to see first price. People used to see first price, कितना सस्ता है, what is the cheap. Now people will see what the best. People are ready to throw more money. We have seen all. I don't want to comment on any operator at this forum. You have seen the voice quality has improved after bringing the new technologies? Undoubtedly, no. Quality is getting deteriorated. We brought the new latest technologies, LTE, voice over IP, voice over LTE. एंड इसमें पैसा कौन बना रहा है? नया ऑपरेटर. पुराना ऑपरेटर पूरा टीडीएम यूज किया है, पूरा ये हो गया है. अभी कौन पैसा बना रहा है? नया ऑपरेटर डायरेक्टली आईपी लाया है. आई डोंट वांट टू नेम अगेन हियर. जो आईपी लाया है वो आर्गुमेंट कर रहा है, सस्ता में डिलीवर कर रहा है. एंड इसका मैनेजेबिलिटी भी बहुत सस्ता है, इजी है. टू मैनेज द नेटवर्क आल्सो वेरी इजी. इंस्टेड ऑफ मैनेजिंग 2G 3G आपको सिर्फ एक ही है, बोले आईपी. बहुत सारा ऑपरेटर धंधा छोड़ के चले गए हैं. आई डोंट वांट अगेन नेम हियर. सी व्हाई सिंगल प्लेटफॉर्म जो है, इट विल बी यूजफुल ऑगमेंटेशन पर्पस एंड अर्ली रोल आउट पर्पस, अर्ली रिजल्ट्स पर्पस. हियर अभी जो हम बात कर रहे थे ट्रैफिक इंजीनियरिंग, क्वालिटी ऑफ सर्विस इज वेरी वेरी अवेलेबल विद दिस. Again, virtual private networks. This is much more today. We will see what exactly the virtual private network is. Creating a tunnel on a public cloud. Otherwise, अगर virtual private network आपको चाहिए privacy के लिए और security के लिए, data confidentiality के लिए, you need to establish a laser line point to point. अगर point to point एक ऑफिस के बीच में आप point to point ले सकते हैं. अगर एक ऑफिस आपका ब्रांचेस 1000 है, 1000 point to point लेंगे क्या? Can you take all 1000 point to point links? Is it manageable? Is it conversable? Is it combinable to a MUX? Again, MUX has gone. Again, your TDM. So, by creating a virtual private networks on existing IP cloud, you can connect point to point. You can connect point to multi-point. It will create a tunnel. ये जो है tunnel एक बनाती है इंटरनेट क्लाउड में. So you create a private network on a public cloud. That's the virtual private network is. Typical example I will talk to you. You people are all using the e-office. E-office is possible to use only in RailNet. Is it possible to use directly on internet from home without having a VPN client and a secured VPN? Anyone can answer that, please?
No.
No. So now you understood how your e-office has been put on a secured cloud. For that to access the secured cloud through internet, you need to have a VPN client. Secured client VPN has to be installed onto your system where you are operating. So how secure your RailNet is, how security your e-office is. So to provide such type of VPN networks for so the VPNs can be created into the MPLS. Again, you will ask, where is a MPLS? Your RailNet is on MPLS cloud of RailTel. Your RailNet is in MPLS cloud, maintained by RailTel.
Yes.
Clear, sir? Other is voice, video on IP. As we spoke about, we have a separate for voice, separate for video. So everything can be converted and mixed with this. Again, there is a challenge. Voice, delay variations, and quality of service constraints. That can be engineered in the MPLS. Now, hopefully, with these 4 points, you understood what is the main purpose of moving towards the MPLS.
Sir, exactly tell the traffic, what is traffic engineering? Exactly. What is
Yeah. Okay, sir. Traffic engineering.
Light should be given on the what is traffic engineering. Please.
Good, sir. Traffic engineering is that how you are routing your modulation techniques. You are having different modulation techniques to transfer the data for distances, lot of distances. Different traffic engineering. What is the packet drops? How much packet drops you can allow? How much delay you can allow of your packet? You can't allow the packet delay more. If the packet delay is more, packet gets automatically dropped. Suppose you use for voice, packet delay is okay. If you are sending for data, data loses the synchronization. So, like that tips. One is the delay, other is the latency. And these are that few traffic parameters engineering parameters. When you start using for engineering video, suppose you are monitoring this video, what you call is video surveillance systems. You are monitoring through this cloud. The quality parameters for the video surveillance will depend upon the resolution and the modulation techniques, QAM4, QAM16, QAM32, and QAM64. So these are the different modulation techniques for getting the resolutions. The parameters what you adjust onto the traffic engineering. These are the typical traffic engineering ports. Our colleagues, when they talk into this traffic engineering, they much debate on it because I don't want to interfere in their discussions. This is only to give a flavor of you a trailer one. Okay, sir?
Then the quality of QAS, just put a light on QAS.
Yeah, QAS is like this, sir. QAS is like this. Let me talk. You are all familiar with voice TDM. Normally, any voice call, any goes, it has got a different parameters which is monitored in India by TRAIA, Telecom Regulatory Authority of India. They decide these are the minimum prerequisites. Voice call should be connected within this time. Call should not be dropped when you are moving from one cell to other cell. The call should not be dropped. If it is dropping, these are the quality parameters and perimeters that is defined for the class of, one is called class of service, other is called grade of service, other is called quality of service. These are the different grades to measure the particular quality or particular parameter of that distribution or the delivery. Just now I told you example of your voice call, the call setup time. Suppose you are seeing nowadays, when you dial a number on your mobile, you are waiting a long time till you get a ring back. Is it not happening in your daily circumstances? Yes or no?
Yes, sir.
Happening. Okay. Why? That means it is not being proper quality of service parameters have not been met. And how many times call get dropped while your conversation call is get connected? So these are the poor qualities of the services. These are the different parameters. This is all what I'm talking is the TDM voice or voice switched or data switched, whatever it is. But when you go back to your IP latency, if the packet is delivered late, suppose you are using a video conference, real-time video conference. If the buffering is taking more, what happens to the, what is the reason of buffering more? Because of the congestion. The congestion is what? Having more load on the network. Why the more load on the network has come all of a sudden? So these are the different quality of service parameters to be maintained to maintain the grade of service, quality of service, class of service. So these are the different parameters of the quality of service. That's why we call, while configuring our VPN circuits and the MPLS, you will come across with my friends talking next 2 days. Class 1, class 2, class 3. They call class of 1, class of service 1, class of service 2, class of service 3. They will talk. These are the traffic engineering parameters which I am referring here. My friends will talk down the line. Class 1, class 2, class 3. Class 1 is a premium, highly paid. Class 2, low paid. Class 3, very low paid. And class 4, no paid. So I'm just telling an example. So this is how you define the traffic engineering parameters basing on the delivery of the service. Is it clear to some extent?
Okay, sir.
Yeah.
Sir, kindly explain, sir, virtual private network.
Yeah, we are going to talk, sir. We are going to talk on that. Just give me 2 minutes. We'll go to the other slide. Yes. We are going to talk on that. We will talk 10 to 15 minutes on that. Applications of the MPLS. You see the word called guaranteed service. Anything is guaranteed in this world? But MPLS assures that. Do keep in mind, MPLS backbones are connected in a ring. It is not a linear. So backbone once fails, alternate route takes. Yes, there may be a delay increased because of increasing the long haul, but the services are guaranteed in MPLS cloud. Traffic engineering, the VPNs, virtual private networks. What is the architecture? Ali sir, tell me when you want me to break for questions or for the second break for tea. MPLS architecture, it combines the scalability and flexibility of routing with performance. You see, the performance is nothing but quality of service and traffic management of layer 2 switching with layer 3 routing. You see, everywhere the world calls QoS, quality of service. MPLS architecture consists of label assignments. It's very simple. You will surprise you. You will understand the MPLS technology in 2 minutes. But how you will implement that, there needs to be studied further for you. MPLS architecture consists of label assignments, path selection policies, and routing and signaling. Everywhere signaling comes. We have a signaling in our PCM. We use the common channel signaling, channel associated signaling, CCS, CAS. This is all on the TDM, PCM. But again, similar type of signalings we use. We use it in voice switching, C7 signaling. We use number 5 signaling, R2 signaling for voice takes place. But for our data to transfer, we have RSVP. In MPLS uses RSVP protocols. We will see what exactly the signaling mechanism, routing and signaling. MPLS architecture, again friends, all of you officers here, I request you, this I'm just taking it, somebody else will talk into the depth. I don't want to intervene in this to make the VPN and other my deployment easy to understand. I'm just touching upon, this is just a trailer made for you. To make ready for understanding further MPLS, I already briefed what is the legacy to MPLS movement in Indian Railways. Just I briefed it. Some of my officers will talk depth onto it. Is a 2-hour session is there for that. MPLS architecture in any network layer routing is decomposed into 2 components. There is forwarding component, other is a controlling component. Anywhere you see, yesterday also we have seen FTP port number 20 and 21. 20 is used for controlling purpose. 21 is used for actual file transfer. The similar way, anything you have a forwarding component and controlling component. The forwarding component, label carried in a packet and label is binded. Information maintained by the router, that is what we call is LER, label edge router. We will see that. Other is control component, used to establish and maintain the route. And label binding information, which path or which switch path the packet has to move in. We will see that. MPLS terminology, we have a datagram, is a generic term that refers to unit of... Yes, sir.
Sir, terminology will start after the break.
Sure, sir. Sure, sir.
Because already we are approaching 11 o'clock.
No problem, sir.
So one small clarification somebody has asked. If you can...
Which that forwards the data graph based on the label residing in VPI and VCA. That is virtual path identifier and virtual circuit identifier fields. MPLS domain is a portion of the network that contains devices that understand MPLS. Again, label switch path, LSP, it is a specific path that a datagram travels through the MPLS network based on the labels that are assigned to the datagram. Label switching is a term used to describe the generic terminology that combines layer 2 and layer 3 technologies. Again, layer 2 switching, layer 3 routing. What is a label? Label is a short fixed length entity with no internal structure. Label does not directly encode any network layer address information. It is only adds, deletes the label. It doesn't do anything into it. Such as source and destination, they can't touch it. Label is applied at the ingress router, that is label edge router, and removed at the egress router. At the end of that router, it will be removed. Inside the network, switching is done by seeing the label attached to the packet, and thus routing and switching function is integrated. That is merging the function of layer 2 and layer 3 technology. I think this is very, if you can understand this, you understood the MPLS. MPLS has only one local significance. Labels can be stacked and forwarding is based on the top stack. We will see that what exactly.
What is the meaning of only local significance?
Local significance, sir, suppose one router to the other router. Suppose one label has been given at one label number, that is up to the next hop of that. If beyond that, it is not. It cannot be end to end. Suppose in between a network, in a core network, you have many label switching routers in between. Label switching routers. We will see. Can I answer this question in next one slide, sir?
Okay.
So that I will show and understand that. Now you are seeing this is the label edge router. There is a label edge router. This is sitting at the ingress. That means input of that network cloud. That is MPLS cloud. And this is sitting at the egress. That is outside of the cloud. For this example, in between you have a label switch routers, LSR1 and LSR2. These are the label switch path. Okay. Now normally IP has come. Packet has come. For this packet, IP forwarding domain has come. Now you are adding one label to this IP, and this IP is moving on this path. Sir, you asked just question, what is the local significance of this label? This label has got only up to this port. When it goes to the other port, it has been given other L2 label. So it has got a local. It don't have up to end. Am I clear, sir?
Clear.
Yeah. So it has got a local significance up to this path only, it not to end. So again, at this router, it checks this label, then it removes that, it adds one more label, forwards to it. Similar way, after going through LSR2 router, it discards this L2, adds one more label. In end to end, you received your IP. How simple it is. If you can understand this, you understood MPLS. Every path label added, label subtracted. Accordingly, we'll have how we used to have a routing tables. We'll have a routing table also. We will see what the routing table is. This is the forward table. Okay. Forwarding table, what we call. You see, this is the ingress router, LER. This is the egress LER. In this ingress LER, the input port is 3. Input port is 3. Output port is 5. Outgoing label for this ingress out is label 12. For LSR1, input port is 2. Incoming label is 12. Outgoing port is 3. And outgoing label, it has been given by this LSR is 34. For this LSR2, input port is 1. Incoming label is 34. Outgoing port is 2. Outgoing label is 5. Egress router, input port is 4. Output port is 3. Incoming label is 5. This is way how the forwarding table keep updating. Yes, sir. Automatically, sir, it is generated by the system. Because we can't keep on. See, just now we are talking only one or two routers in between. In the cloud, you have thousands of routers. No? It is practically not possible to give these addresses. It is given by the system.
Sir,
Yes, sir.
Achha, you told that labels will be changed in between. Okay, fine, everything is okay. When it is starting from the LER 1 to the when it is going to the last LER, so how the what is the destination? How it knows? means
Okay.
so
Good.
normal packet switching. So it will go to the each routing table. It will see the routing table, the destination IP address. Based on that IP address, it will route. So that, but here we are not going to the routing table. But how
Ex-
it will
yeah.
see that path?
Excellent question. Excellent question. In the yes, good question. It is in IP. IP packet has got your source destination and destination address. Okay. Am I clear up to this point? IP address has got packet has got source address, destination address. Default all the time packet stays open short first. Default packet takes OSPF default. Okay. This IP packet has got the destination address. This in the transiting path, you are assigning the labels, not on end to end. Again, when it comes to the egress router, IP has again got the destination address, and it has got also the source address to reach its destination. Is it okay? So label is not changing your packet datagram or packet data information, which contains your source address, destination address, and also your data. Forget about your address, the data. Am I clear?
No.
Not clear. So tell me where you are not clear so that I'll make it clear.
No. My question is, for example, if it is from Vijayawada to Secunderabad.
Yes,
so
sir.
When I am sending the data from Vijayawada, so
yes, sir.
It may go in many number of routes, right?
Correct, sir.
So when how the only in that particular path only this my label has to go. How when it is going to the destination Secunderabad, then only it can know the path. Then only it give the labels. So then,
correct.
So then before you should know the destination, then only it can provide the path.
Sir, all Hyderabad, Secunderabad, all connected in a single cloud. The cloud is common for MPLS. You don't have different clouds of Secunderabad cloud separate and Vijayawada cloud separately is not there. No, sir. It is a common cloud. Okay. In the cloud, when it enters to the MPLS cloud, this IP, which has got the destination to reach, this is only safeguarding the path in the MPLS cloud. You are adding headers, like headers. The labels you are adding it. It is in the common cloud. Your Vijayawada user host has to send a packet to the Secunderabad, or suppose example. So your source and destination known, because if both are into your same cloud only, when it is gone to the other cloud, again the router takes care of. That is called NNI, network to node interface, network to net interface. Suppose the Railtel cloud wants to integrate with Airtel cloud, Airtel Bharati cloud. So this is called NNI, network to node or network to network interface will be interconnected. Then this cloud to that cloud it will go. Is it clear at least now?
No, sir. My simple question is, so
sir,
normal IP addressing when we are sending. So first when I'm sending the some IP address of destination, so my router will check the what is the IP address. Then it will send to the next router. That next router will see the what is the destination address. So again from there, ultimately it will go to the my destination IP. So ultimately everywhere it will check the destination IP address. And from there it will, as per the routing tables, it will send. Right, sir? So here at the ingress router, when we send the packets, so at the ingress router, it is only simply adding the labels, but it is not checking the next time onwards. It is not going to the layer 3. It is not going. Only it is going to up to labels, but labels has to go in the same path. How the ingress router, whether the ingress router will decide the what is the destination before itself, it will know the destination. Then only it will send the labels to in that path. Or how that labels will go to specific to that path only.
Okay, fine. When it enters the ingress of the ingress LER checks the destination of this packet where it has to go. Is it clear so far?
Okay.
Then when it knows the destination at the ingress router, it will pass the packet on different switch routes to reach the destination address of that egress router. Is it clear? I will repeat again.
Okay.
You got it now? I will explain. I will again. See, at the ingress at IP checked the destination address at the ingress LER. So once it leaving out the LER, it knows the destination where this packet has to go. Accordingly, it selects the switching routers in between to reach that egress router of the destination address in the cloud. Absolutely, broadcast. It broadcasts, sir. Yeah. Yes. Because it's a router, no, sir. Router does the broadcasting job. Am I clear?
Okay.
Yeah. Say. So this is how you do the forwarding table in the MPLS cloud. Any questions on this MPLS? This is the only basics I touched. I don't want my colleague to feel that I entered in his area. So you listen from him also, but just the concept I touched upon. And we will talk about the virtual private networks.
Sorry, sir.
सर एक सवाल पूछूं
सर
Yes, sir.
अभी सर जैसा कि इससे पहले जो एक सर पूछे कि LER से जो हम लोग शुरू करेंगे और जो हमारा लेबल लगा हुआ रहेगा, लेबल लगाएगा सो ओनली डेस्टिनेशन के लिए अगर लेबल लगाएगा, नेक्स्ट LSR 1 पे जब आके जब उसका लेबल हटा देगा, नेक्स्ट लेबल जो देगा उसको कैसे मालूम रहेगा कि LER 3 में ही जाना है?
बढ़िया क्वेश्चन है आपकी, अच्छा क्वेश्चन है। आई थिंक सिमिलर क्वेश्चन वो साहब भी पूछे थे।
सेम चीज अभी तक क्लियर हमको नहीं हुआ सर।
मैं समझा दूंगा, कोई बात नहीं। अभी आपका आईपी एड्रेस में, आईपी डेटाग्राम में आपका सोर्स एड्रेस है, डेस्टिनेशन एड्रेस भी है ना, आईपी पैकेट में है ना, है कि नहीं?
यस सर,
आईपी पैकेट में है। आपने ये LER में क्या किया था, एडिशनली आपने लेबल डाला है कि ये लेबल अगले मेरा कोर रूट में अगले स्विच को जाना है। ओके, अगले स्विच को जो जाना था वो स्विच को जाना था कि जैसा मेरा डेस्टिनेशन एड्रेस आईपी पैकेट में है वही रूट का LSR को जाएगा।
ओके,
समझ गया? अभी आपका डेस्टिनेशन एड्रेस किधर जाना है आपको पहले ये LER इंग्लिश को मालूम है ऑलरेडी।
मतलब लेबल लगाने का जो बेस है वो भी डेस्टिनेशन आईपी एड्रेस के बेस पे ही है।
लेबल लगने का अपना ये है कि इन द ट्रांजिट पाथ स्विच करने के लिए इन बिटवीन नेटवर्क में कैसा जाना है, कौन सा रूट में जाना है बोल के डिसाइड करने के लिए लेबल डाला है कि ये नेटवर्क से ए नेटवर्क तक बराबर पैकेट पहुंचे, वो पैकेट में बराबर लेबल के नंबर से पहचाने को कि गलत पैकेट मेरे को नहीं आ रहा है, वो समझाने के लिए लेबल डाल रहे हैं। ठीक है, मगर
ओके सर,
समझ गया सर? अभी
अनिल
सर ठीक है।
This is very important functionality of MPLS. If you are not clear,
please
get it clear. Otherwise आगे नहीं जा सकते हैं. This is only basics of MPLS. Unless it is understood, you cannot go forward.
हमारा सिंपल क्वेश्चन जो
if you are really clear, okay. You are not clear, get it cleared.
Sir, it is not clear.
Sir,
because routing is done on the basis of destination IP address, then what is the need of labeling?
Okay sir, in the network में आपका पैकेट सही जा रहा है, सिक्योरिटी जा रहा है कि आपको कैसा मालूम होगा डेस्टिनेशन एड्रेस आपके अगर MPLS नहीं होगा तो भी आपका पैकेट सोर्स से डेस्टिनेशन जा रहा है ना, जा रहा है कि नहीं जा रहा है?
यस सर,
जा रहा है ना। अभी आप एडिशनली ये क्यों कर रहा है कि आपका पैकेट जो है एग्जैक्टली डेफिनेटली एश्योरेडली जाना है, वो भी करेक्टली जाना है, सही जाना है। उसी के हिसाब से आप क्या कर रहे हैं, जिधर मेरा, अब देखिए आप इधर से टेक एग्जांपल, आप इधर से ट्रेन में जा रहा है, आपका ट्रेन सही रूट में जाना है कि आपका रूट डिफाइंड है, सो इट विल गो ऑन द सेम रूट, है ना। अगर आप अल्टरनेट रूट जा रहा है टू रीच द डेस्टिनेशन, सो आपको कैसा कि आप सही जा रहा है, कोई आपका आइडेंटिफिकेशन होना है कि एक गाड़ी ट्रेन नंबर सो एंड सो आ रहा है। सो बिटवीन टू routers in the path, you are giving a label between that. Some officer has asked what is the, some officer has asked me, what is the local significance? The local significance जो है between one router to router in the path. In the path from source to destination of particular packet, that is only that label. When it goes to the other router, it given other label. आगे आपको अभी समझा नहीं समझा तो मैं वापस बता दूंगा.
Sir, if it is possible, please show in one presentation how the packet is traveling from source to destination in normal IP network and in the MPLS network. Please show that presentation.
Sure. See, sure.
Yes.
Sir.
Why don't you use whiteboard with writing something?
No, I can do that. I can do that. Not a problem. See, just simple, sir. The answer is also, question is very simple. They ask, not a problem. See, to answer them, normally in normal IP routing, forget about MPLS, the packet contains source asset and destination address. By seeing the destination address, packet transits on a network. Okay? Packet has got a different options. It can go on a wrong route. It can go on a short route. Default packet takes a short route. Okay, if the shortest route got congested or network got break or down, so then it will go on a long route, but packet reaches the destination. There is no doubt on this. The same way the packet transits. Is it clear so far, sir? Sir, is it clear?
Yes.
Okay.
Sir, actually, what is the problem is what I understood. Here you have shown LER in between LSR. Okay, in LSR we have an IP as well as label. So we understood the port also. What is incoming port? What is outing port? Only thing is, let us say, what is the label? So incoming label is 12, outgoing label is 34. Something you told. Okay, na?
Yeah.
Label is 12. So who will decide that incoming label is 12? Outgoing label is 34. This was not understood by all the people. What I'm hearing.
No problem, sir. I will make it. I will make it.
Only thing is, who will say this is incoming label 12 should go to the 34, and what is the incoming label of 34 should go to the outgoing label of 5. So that please explain that part. What is that part? There people are lacking actually.
Good. No problem. I will explain now. You see, IP packet has entered into the LER. This LER knows at the ingress level the destination of this packet. Okay. This label is added at the ingress output side. That means this label edge router at the ingress added the label to ensure this packet reaches the next hop correctly by this LER. It is assigned by this LER to ensure the transition between LER to the LSR1. So far, so doubt? Any doubt on this so far?
Clear. Up to here, clear.
Fine. At this LSR1, it checks whether the packet sent by LER with the label 12, I received correctly. That is by seeing this LSR table. LSR table, what is? It knows that incoming label 12 is coming assigned at LER at the ingress part. Is it clear?
Okay.
Is it clear, sir?
Okay.
When the packet is reached safely for me at LSR1, what it does, it extracts the label 12, removes the label 12, add one more label number 34, and send it to the next LSR router in the network. So far, so good?
Okay.
That is added.
This label numbers are randomly selected?
It is randomly selected by that device. It is not randomly, sir.
Randomly. It needs to be randomly selected.
Random, sir. It is random.
Sir.
Sir, for the means same source and same destination, for the next subsequent packet, there will be change in the label. There may be
absolutely. I think that's good part you asked. It is not necessarily the same label. It is a very different number. It's like OTP, sir. How OTP changes every time for us.
Right.
Clear? Then at the LSR1, IP is not touched either anybody in the cloud. Then it has added LSR1 added 34. So outgoing packet he has labeled in his table as 34. Then the total datagram is entering to LSR2. LSR2 checks this LSR table. Input port it is entering 1. Incoming label as 34. And this LSR2 removes the packet 34 and adds the packet 5 and delivers out of this LSR port number 2. So far so good?
Okay. Okay.
At the egress router, it is entering into this table, you see, entering into the input port for this egress LER is port number 4, output port number is 3, incoming label is 5. When it has come to 5, it is already in the table, it checks, yes, I received 5, it attracts the label 5 and it takes out the IP. So far so clear?
Yes.
But how LER add the label, incoming label is 5?
No, it removes the 5. It removes the 5. See, 5 has come. The 5 is assigned at LSR2. LSR2 से लेके LER एग्रेस तक आने के लिए बीच में जो पाथ में आपका लेबल था 5.
वही वो LSR2 5 ही ऐड क्यों किया, दूसरा क्यों नहीं किया? उसके लिए कुछ बेसिक तो होगा.
नहीं, आप अगले पैकेट आएगा तो उसको 10 देगी, अगला पैकेट आएगा तो 20 देगी.
आप LER में इनपुट लेबल 5 दिए हैं, इसीलिए LER में आउटपुट, LSR में आउटपुट लेबल 5 जोड़ रहे हैं सर.
वो 5 देखेगी, 5 को निकाल देगी.
वो जी ये ट्रेडी आपको क्या है ना, ये लेवल कुछ भी हो सकता है. इन्होंने एग्जांपल लिया 5 करके लिया था.
नहीं
एग्जांपल के लिए नहीं लिया. LER में 5 है लेबल, इसीलिए यहाँ पे 5 ऐड हुआ है सर.
नहीं यार नहीं सर, बात सुनिए. LER में देखिए, 1 मिनट सर, 5 ऐड नहीं हुआ सर. 5 इज गिवन बाय LSR2.
यस सर,
LSR2 ने 5 दिया है.
हाँ,
ये 5 को ये LER एग्रेस रूटर में देखेगी, मेरे को 5 आ रहा नहीं आ रहा, एज पर दिस LER टेबल. नीचे LER का एग्रेस का टेबल में इनकमिंग लेबल फॉर मी कमिंग फ्रॉम LSR2 is 5.
Sir,
Yeah,
sir, can you hear me, sir?
please, yeah.
सर इसका अर्थ ये है क्या कि जो लेवल है वो केवल एरर करेक्शन और एक्नॉलेजमेंट के लिए यूज किया जा सकता है, 100% चेंज होता रहता है?
100% you have come to this point. It is to ensure.
हाँ, तो सर इसका अर्थ ये हुआ कि जितनी बार डाटा आएगा, जो भी डाटा आईपी में आ रहा है वो सोर्स और डेस्टिनेशन एड्रेस लेकर के आ रहा है, लेकिन केवल एक स्विच से एक राउटर से दूसरे राउटर तक जाने के लिए एक एरर करेक्शन और एक्नॉलेजमेंट के लिए लेवल दिया जा रहा है. और जब वो अगले होप तक पहुंच जाएगा तो वो उसको कट कर देगा, आगे से दोबारा जो दूसरा होगा वो दूसरा लेवल निकालेगा, और इसके बाद जब सेकंड डाटा.
Yes sir, जिंदाबाद for you. That is what it is. At the LSR1 पैकेट 12 निकाल दिया, 34 ऐड किया. एट LSR2 में 5 ऐड किया. आपका घर आने के बाद आपने निकाल दिया 5 को. आपका जो आईपी चाहिए था वो ले लिया. आईपी में आपका डेस्टिनेशन एड्रेस है, वो पैकेट डेस्टिनेशन पे पहुंचा जाएगा. क्लियर? इज इट क्लियर?
थैंक यू
sir, LER and LSR are same device, sir.
See, it is sitting. See, no. LSR is only switching purpose. LSR label switching router, whereas label edge routers are terminating. See, LSR don't know what is the source and destination address of the packet is. Only LSR knows.
Huge network, all are maybe LER, no sir. So many network will be.
No sir, that's what I'm telling. See, all are, see, the packet where enters first to assign the label, that is called ingress router. The packet where it exits by extracting the label is called LER egress. In between, whatever comes for switching this packet to transit between LER ingress to the LER egress, there are switching paths. Okay?
So how to accommodate this, sir? This one.
This will be done by the system. This will be done by the system, sir. We no need to break our head on this.
Okay.
No.
Yeah, please go ahead, sir. Every packet will change, sir. Egress router or ingress router? Egress router. That is, yeah. Okay, along with this datagram, the routing table also been forwarded. The routing table is containing the label file. This is the label file. Then extract the label file at the egress router. Not predefined. It is, sorry, see, what happens in a router, it keeps adding these packets, keeping updating the routing table, keeping updating, broadcasting to the egress router from the LSR. Yes. No, it's sir, it is microseconds, it happens. It is a process system. It happens, don't worry, it happens.
Sir, one doubt, sir. How come these people, I mean, it was told that MPLS routing will be much faster than normal conventional routing.
Yeah.
By adding labels and decoding it or adding, it will definitely cause a delay. So that's what I understand how it is being defined as MPLS routing is faster than the conventional one.
Sir, okay, fine. Let me explain this way. It's all in a cloud, MPLS cloud. Okay. The packet adding and subtraction is in the path. In the path, if there is already connected, the route selection is end to end. In between, there is no LSRs, suppose. Then one point only ending, one point is only extracting. Again, you see, you imagine what could be the delay for adding and subtraction in any systems. It is not like a physical manually handling, adding and subtracting. It is the system. Suppose in the LER, here you are finding two LSR in between ingress and egress routers. Suppose there may be only one, there may be 100. If that 100 end-to-end is defined, which is bypassing all this LCR, packet taking shortest path, then what is the delay, or what is how many times you add and subtracts? So it won't take, it's a micro seconds, a nanoseconds rather. Yes, sir. Please, sir, please. Sir.
One Friday, what he has asked, no, so doubt why it is a slow or fast.
Sir,
so his name is also.
MPLS technology is directly, sir, as a ring connectivity.
Yes. Is totally ring
connectivity is not working.
Absolutely. Ring. मैं इसे पहले बता चुका हूँ. The backbone is totally on a ring. If one path fails, other path will take over.
ओके सर, फिर तो राउटिंग हो जाएगी, जिस रूट से उसको पाथ मिलेगा उसी रूट से वो उसको पैकेट को भेजना चालू कर देगा सर.
100%. इसलिए पैकेट ऑल द टाइम शॉर्टेस्ट रूट लेगी, वो SPF प्रोटोकॉल से. Is it clear, sir?
आउटपुट सर, इसका आउटपुट ईथरनेट होता है सर?
Yeah, Ethernet, 100% Ethernet. Or optical also you will get it, because the big path can't be given on this thing. You will have a SFPs, you will use SFPs, you will have a this thing handoff of Ethernet also.
सर क्या इसमें संभव है कि STM को आइसोलेट किया जा सके?
क्या सर, दोबारा बताइएगा आपका क्वेश्चन?
सर जिस तरह से हम PRS में मॉडेम राउटर्स प्लस STM यूज करते हैं, तो अगर हम MPLS बेस्ड PRS यूज करेंगे तो उस कंडीशन में संभव है कि हम अपने मॉडेम राउटर्स और यहाँ तक कि STM को आइसोलेट कर सकें?
अभी देखिए सर, ये तो है पूरा IP है. STM means a TDM part. This is coming purely on IP. ठीक है सर, इसलिए हम इसको IP MPLS कहा गया था. आपका STM जो है TDM नेटवर्क में है ना?
The question is in even STM in SDH equipment also we are extracting the IP, no, using the TP01 card or something, then it is again we are transmitting the IP only.
So, but on the transport, sir, you are using a TDM by using the card. It is going SDH, no, sir, end to end. It is not an IP, no, sir.
Yes. The end to end is TDM only. I mean, even.
Yeah. Yes, sir. Yes, sir.
So now the question is, can we connect our this MPLS network to the existing SDH network using this converter card that is called TP01 card or IP card in the SDH? Can we use the same SDH network?
Sir, that becomes again, we were just now discussing before the break, that is MPLS transport TP.
So that's MPLS TP, whatever I told, that is MPLS TP.
Yes, sir.
Purely MPLS means completely from end to end, totally IP. That will be there in between.
Sir. It is like, sir, even if you can recall that ATM technology, in ATM technology, it is a technology existing before the MPLS, the voice, which is on TDM, the data, which is on IP, video, mix of both, is pumped on the same ATM by creating VPCs, VPIs, virtual circuit identifier, virtual path identifier, and all. I think we can recall the ATM. The similar way, in ATM, on the common platform, you are able to send all the three by creating a virtual private identifiers, virtual private circuits, virtual private paths. Am I clear, sir?
Yes.
Yeah. Shall we move or we'll stick to this slide for some more time? No problem.
Yes, a simple one question, sir. Our one simple question is there, sir. In our railway scenario, if we replace all the way station with the IP MPLS router, shall we remove STM equipment or PDMux by using all the instrument on IP base?
Yes, sir. The idea is that because you will have a backup, MPLS is anyway on ring, but still to have further backup, you can keep even ISDN line also if you require. So MPLS anyway and a backbone on a ring.
Sir, his question is only whether our PDMux and SDH has to be removed or not.
That's again a call of the call of the management, sir. If you want to still keep as a backup for some time, you can keep it up till your network gets stabilized fully. But to be frank, sir, today we are all using your bank accounts. All banks in India, each bank has got many branches. All are connected on MPLS VPN network only. I'm going to show how even RailTel connected these things. So all these MPL connectivities are already existing, working 100% there. So similar way, nothing wrong even to connect your rail network once it stabilizes. You can take a call after that. Sir, take example of even your connectivity of our networks, SDH or something. For monitoring your SDH network, you are using in-band signaling for monitoring for DCN network, communication controlling networks. For backup of the communication network, you may be taking other Bharat Sanchar line to have a backup for that controlling purpose. Are we doing it or not, sir?
Yes.
We are doing it. Similar way, if you still your network stabilizes or still you want a backup for critical operations of your railways, you can keep another existing network as a standby for some time. So again, this is the call of the management or the leadership team to take it. But you see the typical example of banking, how we are doing today. Remote ATMs, which is at the spot villages, we are connecting through VSATs. The VSATs, you are combining VSAT communication, you are combining optical communication, you are combining copper DSL communication, you are combining broadband communication, all together bringing and terminating in bank MPLS network, including international branches also of bank.
Anil?
Yes, sir.
When you are going to have all services, IP-based services, okay?
Yes, sir.
So you can have only IP-based networks. You don't need to have a STMs, PDMX, all these things. But we are having now E1 based service, Ethernet based services, some other point-to-point services. We cannot have same network. But if you have suppose you take one station, there is a PRS IP network, UTS IP network, voice IP network, suppose exchange IP network, your IP based TVs, IP based data logger. If all are having IP based services at one location, those can be transported through router to the headquarters. Nowadays, the routers are coming with 10 Mbps, 10 Gbps, 100 Gbps interfaces.
Okay, sir.
Well, one interface is enough for all the services because we are getting 10 Gbps.
Actually, sir, why we are asking in our Hyderabad division, the coded life of STM equipment and PDMux is over. So now we are planning to replace. Shall we replace entirely with the IP MPLS in spite of STM and PDMux?
If you are going to plan entire section IP based, then it is possible. Suppose one section, if you want to plan complete IP based services.
Yes.
Every station is given one router and connected to OFC 10 GB or 100 GB network, and you put one layer station. Okay. So here one port, UTS another port, voice another port, VoIP another port, like that.
You are having control communication, it is still on conventional system only. So
that's right. We cannot go.
Only we are planning if we replace our control system on IP, then it is possible or not?
No. Even that traditional Narasimha, that traditional control system also can be integrated with IP because this MPLS, we can derive even circuits through MPLS. Point-to-point even circuits.
Sir, again, still MUX is required, na, sir?
No, point-to-point even circuits.
See, sir, still we are using 64 kbps. So,
Narasimha, suppose even to Ethernet, what does it mean?
Right,
even
sir,
to Ethernet,
sir,
what does it mean?
Right, sir, even is okay, sir, but still we are requiring demultiplexing of even to 64 kbps, sir.
No. If you want to go further 64,
sir,
still you can go, but the backbone network can be IP.
Sir.
And the network, the end users can be still even. Because even to Ethernet simple converters.
Sir, you can eliminate STM, but normal PDMux is compulsory.
Not required. Suppose in place of 64, you are going to use E1. There are all converters are available in the market. 64 to Ethernet, E1 to Ethernet, serial to Ethernet. Only thing is you have to use converters at the user end.
Okay, sir.
Backbone can be.
Sir, you have told rightly. I will like to add you 2 points, sir. You have told rightly. Sir has told rightly, even to Ethernet converter. We at Railtel recently we have delivered one circuit at Wadi cement factory for 5 circuit. Whereas where we don't have our TDM network there, we have an IP network there. We have given on our MPLS even there, and we converted Ethernet to the E1 and we have delivered E1. That is one aspect. Sir was talking earlier that 5 circuits and different departments. All these departments in this network, you can create separate VLANs. We spoke long on VLANs few minutes back. About each department, you can create one VLAN. One person sitting in Hyderabad can talk to the 5 circuit sitting in Wadi, who is his controller. So all these people will come in one VLAN. They can talk on the same cloud. Am I correct, sir, for your applications?
Sir,
Yes.
sir, actually can we get even from the MPLS router?
No, you say you will get Ethernet, sir. Yeah. MPLS ports will have different bandwidths. MPLS will have different bandwidths. You can define.
I'm talking about G703.
Sir, G703 is on your TDM. It is not on, the standard is not for your IP based one.
Sir,
2 Mbps, see, Ethernet out. Sir, if you open the pipe of Ethernet, the same Ethernet pipe, you can give 10 MB also, 2 MB also, your 150 MB also, or 1 Gbps also. Only the Ethernet should able to cater. If it is a gigabit Ethernet, it takes same on the pipe your gigabits.
Sir, Anandan sir, what he told now, you can be point to point V1s in that also.
Yeah.
Yes, sir. Yes, actually, that MPLS another benefit is L2 VPNs. That means whatever you circuit you inject, E1 or ATM or Ethernet or whatever it is, we can derive other end. That is L2 VPN.
Yes.
Even if not doing the TDM, sir. Our existing
Here, see that TDM data is carried over in the form of Ethernet, and other end that same TDM can be derived. So here the advantage is between router to router. If you have a 10 GB interface, 10 GB connectivity, so you can just pump any type of service, any type of TDM or whatever it is through that 10G, and other end we can derive whatever the original side is connected. That is the L2 VPN, and L3 VPN purely IP based, but L2 VPN, whatever physical interfaces are connected at one end, the same way other end we can derive. That is L2 VPN through MPLS or any VPN, even this one. Only thing is you should have a sufficient bandwidth between the nodes, that is routers. So everything is possible. Everything is possible by IP networks.
Sir, what Anil said, now we can replace the STM, so we can directly take the input from the E1 and we will convert it to we will convert that to MPLS router. At the end, we will take again E1 and we will connect it to PDMux. Will it work or not?
Yes, definitely, 100%. See, at our research, sir, in our research, we derived E1 circuit and connected to our PRS network through LAN extenders. Through LAN extenders. See, please.
Ethernet circuit can be derived, sir. There is no issue.
Okay.
Circuit can be derived.
Ethernet circuit can be derived and transported through Ethernet. E1 circuit can be derived, transported through Ethernet. All vice versa also possible. Once you are converting Ethernet to E1, E1 to Ethernet, it's possible. So you derive one E1 from STM and transport through Ethernet, and again other end you can derive E1. Or you just
That's possible, sir, but vice versa is not possible.
Why vice versa is not possible?
Vice versa is not possible, sir, because we can derive the E1 from a service. Suppose the trial net is, we want to extend trial net from Secunderabad to some other remote location. We will insert the Ethernet.
One example I will tell you. Suppose both of you want to use PDMux. Okay, PDMux. There is no STM. Now I can use one Ethernet to E1 and other end also Ethernet to E1. I can derive four wires there. I will connect to PDMux. So below the PDMux, I can derive 64. It will
not work, sir. Actually, what that Seema sir told just now only, na, we actually tried for Wadi link, we are used MPLS router as a backbone, but we are used serial to Ethernet converter. It will transfer for particular converter is required, sir. So vice versa is not good.
That's why particular converter E1 to Ethernet both end. E1 to Ethernet both end and connect PDMux to PDMux.
No, sir. E1 to Ethernet converter is to convert Ethernet to E1, sir. Not from E1 to Ethernet.
Once it is converted to one side, definitely it has to convert another side, boss. It is simple logic. Both-way communication, how do you establish? Once it is converted to E1 to Ethernet, definitely it will convert Ethernet to E1.
Other side it will convert Ethernet to E1.
Definitely. Both sides, both. See, simple logic. Suppose media converter, what it does? Electrical to optical, optical to electrical. Again, vice versa, it should be there.
Yes, actually, we are mapping the
Anand sir is right.
Maybe you are using substandard converter. Use standard converter like MRO Tech, like JXL. definitely you will get this service, no problem. Anyway, that is the idea. It is possible. Remember, it is possible to try later.
Anandam sir, this can be done in offline, this discussion.
Okay,
Yes, sir.
Anandam. Anandam, now I think we had a lot of heated discussion during this session. I think everybody is looking for a good break. So we take 10 minutes break and we join exactly at 12:15. At 12:15, DS Rao sir will continue. And this type of some private clarifications, I think all the faculty can directly interact with the individuals so that it will not consume the course timing. That is not my request to all the participants. Lengthy discussions will definitely hamper the training. So, DS Rao sir, we can take 10 minutes break. After that, we can resume.
Sure, sir. Sure, sir. But really, I enjoyed the discussions because the people are so curious. They were really. I appreciate their this thing, sir. No problem.
This is not like a common preaching platform. This is basically a learning platform.
Yeah, correct.
All the people have with a lot of interest and they got nominated and joined this course. All
Correct.
serious about the